Here's a query on a table with 2.8 million rows. It takes about 4 seconds. So you do the obvious thing. You add an index on the column you're searching. Then you run exactly the same query again, and it takes 6. That's not a bug. And it isn't a badly written index. It follows directly from what an index actually is. So let's build one from nothing. This is the table. 2.8 million rows. You're looking at 40 of them. 4 columns. You want one user by email. The database has no idea which row that is. So it starts at the top. And it checks every row until it finds it. Row 8. That was luck. It could just as easily have been row 2.8 million. And that is the number it has to plan for. An index is a second copy of some of your data, kept in order. So take a copy, not the whole row, one column, plus a note saying which row it came from. That is an index entry, a value and a place. Now do that for every row, and put them in order. That's it. That is the entire object. It's the index at the back of a book, sorted by topic, and every entry points at a page. Now ask exactly the same question. It jumps to the middle, decides which half to keep, and repeats. 4 looks, instead of 2.8 million. But now you have 2 of everything. Insert one row. The table gets written once, and the copy has to be updated too, in exactly the right sorted position. One insert, 2 writes, and nobody stops at one index. Someone adds one for every slow query. One at a time over about 2 years. And nobody ever removes one. So a single insert into this table now does 7 writes. 6 of them are for copies of data you already had. Now change the question. Instead of one exact address, ask for everyone at the same company. The copy is still sitting there. It just stops helping. Skipping only helps if there is a lot to skip. Half the rows match. There is nothing left to skip. And remember, the copy never held your row. It held an arrow. Follow one, that's fast. Follow 500,000. Landing somewhere different every single time. You would have been quicker reading the table straight through, which is exactly what it does. Ask it, and it will tell you so in plain text. The planner isn't ignoring you. It did the arithmetic. Here is where most people get caught. Your query has 2 conditions, so you build an index on both of them. Country first, then email. And in order now means something more specific. It is sorted by country. And then, inside each country, sorted by email. It's a phone book, sorted by surname and then by first name. Ask for country and email and it goes straight there. Ask for country on its own and it still works. Because country is the first thing it's sorted by. But ask for email on its own. And there is nothing it can narrow down. A phone book sorted by surname cannot find you a first name. That's the leftmost prefix rule. And it is why your index gets ignored. There is one more thing this object can do. Remember the arrow. Every lookup follows it back to the real row. Because the copy only holds part of the row. But what if it held everything you asked for? Add the column you actually wanted to the copy. Now write a query that only asks for those. The copy already has all of them. So it never follows the arrow. It never touches the table at all. That is the covering index. The second copy became the only copy it needed. So, 2 numbers. They have been on screen this entire time. What a read costs you. And what a write costs you. Every index you add moves one down and the other up. Which makes, should I add an index, the wrong question. The question is which queries, how often they actually run, and what you're willing to pay on every write to make them fast. An index is a second copy of your data kept in order. Once you have that sentence, you can work out the rest yourself.